US Physics Olympiad, year 2014, USAPHO. Final exam. Problem 8.3. When studying problems in special relativity, it is often the invariant distance ds between two events that is most important, where ds is defined by this equation, where c equal 3 by 10 power 8 meters per second is the speed of light. Question A. Consider the motion of a projectile launched with the initial speed v0 at angle of theta 0 above the horizontal. Assume that g, the acceleration of free fall, is constant for the motion of the projectile. First, derive an expression for the invariant distance of the projectile as a function of time t as measured from the launch, assuming that it is launched at time t equals 0. Express your answer as a function of any or all of theta 0, v0, c, g, and t. Question 2. The radius of curvature of an object's trajectory can be estimated by assuming that the trajectory is a part of a circle. Determine the distance between the end points and measuring the maximum height above the straight line that connects the endpoints. Assuming that we mean invariant distance as defined above, find the radius of curvature of the projectile's trajectory as a function of any or all of theta 0, v0, c, g. Assume that the projectile lands at the same level from which it was launched, and assume that the motion is not relativistic, so v0 much less than c, and you can neglect terms with v over c compared to terms without. Part B. A rocket ship far from any gravitational mass is accelerating in the positive x direction at a constant rate g, as measured by someone inside the ship. Spaceman Fred, at the right end of the rocket, aims a laser pointer toward an alien at the left end of the rocket. The two are separated by a distance d, such that dg much less than c square. You can safely ignore terms of the form of this one. First question. Sketch a graph of the motion of both Fred and the alien on the space-time diagram provided in the answer sheet. The graph is not meant to be drawn to scale. Note that the t and x are reversed from a traditional graph. Assume that the rocket has velocity v equals 0 at time t0 and is located at position x equals 0. Clearly indicate any asymptotes and slopes of the asymptotes. Second question. If the frequency of the laser pointer as measured by Fred is f1, determine the frequency of the laser pointer as observed by the alien. It is reasonable to assume that f1 much greater than c over d. Question 2. If the frequency of the laser pointer as measured by Fred is f1, determine the frequency of the laser pointer as observed by the alien. It is reasonable to assume that f1 much greater than c over d.